All right, pre-cal, here's the homework for 10.7, which was 8 to 124, multiples of 4. Again, if it's repetitive, it's very repetitive until you get to the end, and then, boy, they get pretty rough. Once you get to like about, I don't remember, in the 80s or 90s or 100s or something. But up until that point, it's kind of the same thing over and over. It's number 8. This is in polar form, and you got to turn it to rectangular. X equals -1 times the cosine of -3 pi over 4. And the y value is going to be equal to -1 times the sine of -3 pi over 4, which is -1. That is -3 pi over 4 is -135, which is a 45-degree reference angle in quadrant 3, which is -√2 over 2 and -√2 over 2 for this one. So it's -1 times -√2 over 2. And then a negative times a negative is a positive. So it's √2 over 2. And this is -1 times, and again, the sine of a 45-degree reference angle in quadrant 3 is also -√2 over 2. So √2 over 2, and there's that ordered pair. √2 over 2, comma, √2 over 2. Number 12 is -3. Oops, can't see it. It's -3, 11 pi over 6, which is a 30-degree reference angle in quadrant 4, right? So again, same formula. It's going to be r cosine of theta, and the y value is going to be r sine of theta. All right, here we go. The cosine of 11 pi over 6 is, I was going to say negative. It's positive √3 over 3. So it's going to be -3 times √3 over 3. And then those 3's cancel. So it's -√3. And then this one's going to be equal to -3 times, and the sine of 11 pi over 6 is -1/2. So it's -1/2. And then the negative of the negatives cancel. So it's going to be 3 over 2. And this is going to be -√3, comma, positive √3 over 2. And just to talk about it, let's talk about it. So if I'm in the fourth quadrant, right, in the fourth quadrant, and that's the positive direction for the fourth, I'm going a negative r, which means I have to go from the pole, I have to go this way, which would be a -x positive y, which is what I did get. Okay, next one. This is number 15, is √2, comma, 2.36. Notice there is no degree symbol. That's in radians. My goodness. Certainly not a unit circle value. It is time to get a calculator. And does it say, it doesn't say how many decimal points. Let's go, what the heck? Let's just go 1. Okay, now you better be in radian mode, but still it's the same formula. X equals r times the cosine of 2.36 radians. Let's just get that one first. And that is the square root of 2 times, make sure you're in radian mode. Square root of 2 times the cosine of 2.36 radians, that is. And it's almost exactly, it's -1.0037. And this is going to be y equals the square root of 2 times the sine of 2.36 radians. Square root of 2 for square root of 2 for times the sine of 2.36 radians. And that's damn close to +1. It's 0.996. So if we're going to 1 decimal point, I think I would put the 1 decimal. I would put that 1 decimal point in. I would write -1.0, comma 1.0, because it wasn't exactly -1 and +1, right? This one, you can't see it. It's 0.996, pretty close to 1.0 for that. All right, let's keep going on for 18. It is -5, comma, -2.36 radians. Good thing I'm still in radian mode. So the x value is going to be r cosine of theta. And the y value is going to be r times the sine of theta. going to be negative 5 times the cosine of negative 2.36. And that's about, to the nearest tenth, I'm getting 3.5. Yep, positive. And the other one is negative 5. I want to do it again. Negative 5 times the cosine of negative 2.36. Let's make sure. Yeah, that's what I get. And the y value is negative 5 times the sine of negative 2.36. And that's 3.5 about. Okay, rounded. These are both rounded values here. So I always want to list them as the ordered pair that they are. 3.5, 3.5. Don't just leave it like this, please. I would take a half point off for you never listed the point as a ordered pair. All right, 21. I know it sounds picky, but still. Okay, now, no, we're still going the other crap. Okay, for these problems, it says the plot. I didn't read, I should have read, but that's good. We got good practice here. Okay, I want to do this for only the first two, and you will have to do this on the test. This is in the year 2022. I can't guarantee any other year. All right, and I did do examples like this in class, but here we go. Ready? If I limit theta to be an angle between negative 2 pi and 2 pi, if I limit it to be some angle, what are three? This is on the test. If the book says 2 other ways, I'm going to ask you for 3 other ways. Name 3 other ways that you could describe that point, So I'm going to do this. This is important to do. I want to kind of look at it just real quickly. Here's a circle. Oh, yeah. There it is. And I have to go -1 in the negative 3 pi over 4, which is 135. So negative 135, remember it's negative u clockwise, so that's here, right? So this is the positive direction for it. And from the pole, that would be the negative direction. I have to go -1. So we're talking about that point right there with a reference angle of 45 and the radius being 1. Okay, and remember it's r theta. So if this is it, well, clearly, at least I think the easiest way would be call it 145. That's one way to do it. All right, this is 1, 45. And then another thing I could do is I could go negative 135 and -1. Got that one. I got that one. What if I went this way? What if I went this all the way from here? I went this way all the way to 225. I went 225. So this is the positive for 225, and this would be the negative. So this would be -1, 225. I better put the degree symbol in. And let me make sure that we can see this. The other one that's already given to me was -3 pi over 4. I'm doing it in degrees, but whatever, right? So these always come, here's, you guys watch. These always come out to be 2 of the r values of the 4. 2 of the r values will be positive, and 2 of the theta values will be positive and negative. So let me say it that way. 2 will be positive, 2 will be negative for the r. 2 will be positive, 2 will be negative. Now let's look at it. We got positive, positive. We got negative, positive, which this is negative, positive. So the only one we don't have is a positive, negative. So it's going to be 1, and now we have to think of that negative angle that we'd have to go 1. So this is going to be, we'd have to go all the way around in right here, a negative angle. This is going to be 180, plus 90 would be 270, plus an additional 15 would be -315. So I'm going to write -315 degrees. Of course, I could do -7 pi over 4. I could do all these, right? 5 pi over 4, pi over 4, if I wanted to do it in radians. Okay, I want to do that one more time. For a different angle. And that's going to be negative, because it's not going to be this radian stuff. Although knowing how to do it in radians shouldn't be a problem either. But anyway, it's not going to be radians. Here we go. I don't think. If it's something like this, a unit circle value, I wouldn't feel bad that it's in radians that way. But that's 330 degrees. That's 330. So let's talk about it. And let's pretend like that circle has a radius of 3, because that's kind of what I want to use here. So 11 pi over 6 is this way. So that's the positive direction for 11 pi over 6. But I want to go -3. So that's still going to be a 30-degree reference angle this direction. So that means I'm going out three with a 30-degree reference angle, which is 150, right? All right, here we go. I got to come up with 4 ways to write this. One is already given to me. One way is -3 comma 11 pi over 6. Let's talk about it. Remember what I told you. To be a negative positive, negative negative, a positive positive, and a positive negative. So all the sign kind of things will be changing. So let's go ahead and do this one. Let's go, this negative angle to here would be -180 plus 30 would be -2, -210. And that's so -210 would be here. So it's the positive direction for it. And it would be 3. Then the other thing we could do is we go positive 150 degrees, positive 150 degrees, and that's the positive direction for it. So this would be 3 comma 150. And then the last one, remember this is negative, positive, positive, the last one, because it should be even number of 2 and 2. So because that's negative, we have 2 positives, it could be a -3 times. And I can see here that's a positive angle, a positive angle. So this other one's going to have to be a negative angle, right? So I'm going to have to go, this one is going to be -30 degrees. So that'd be the positive direction for -30. But I want to go in the negative direction for -30. So it's going to be -30 here. And there would be the 4 ways to describe that. That point right there, if we restrict that theta value to be an angle between 360 and -360, or between 2 pi and -2 pi. Okay. All right. So I did want to say that because that is a test question, and I didn't read the directions, but they do ask you to do that. Now, I didn't do it for the two values that were like 2.36 radians and -2.36 radians, but we could, but I don't think I will. All right, here we go. What one were we on? 20. 20 is 0. 20 is 0, -pi. Okay, ready? So we know that x is going to be equal to r cosine of theta, pi, a negative pi, excuse me, negative pi, and y is going to be equal to r sine of -pi. Well, the cosine of -pi would be right there. So it's going to be -1. Cosine of -pi is -1. Oh, r is 0. R is 0. So that's 0 times -1, which is 0. And that's 0 times 0. The sign of -pi is 0. 0 times 0 is also 0. It's the origin then, which makes sense, right? If I go out 0, I don't go out at all. I start at the pole, and I go in the -180 degree direction, 0. I still am at the pole. So 0, 0. Number 24 is 1 comma 5 pi over 4, and here we go. X is going to be equal to r cosine of theta, which is 1 cosine of 5 pi over 4, and this y is going to be 1 times the sine of 5 pi over 4. That's a 45-degree reference angle in quadrant 2 of 225. That's going to be 1 times, here, I'll just write that, 1 times the cosine of 5 pi over 4, which is -√2 over 2. And it's going to be 1 times the sine of 5 pi over 2 is also 5 pi over 4 is also -√2 over 2. So as an ordered pair, it's -√2 over 2, comma -√2 over 2. Alrighty, and now 28. I almost said 27 because we do multiples of 3 a lot of times. 28 is, you can see it's kind of repetitive. -3, 5 pi over 6. All right, so the x value, well, I should read the instructions. Okay, I'm doing it right. I'm doing it right this time. So it's going to be x is r cosine of theta, and y is equal to r sine of theta. Okay, this is going to be equal to -3, and the cosine of 5 pi, damn it. And the cosine of 5 pi over 6 is -√3 3 over 2. Two negatives cancel, and that's going to be 3 root 3 over 2. And for sine, it's -3, and the sine of 5, it's 5 pi over 6 or over 2. 5 pi over 6 is going to be 1/2. So it's -3/2. So it is 3 root 3 over 2, comma, -3 over 2. And 32. Uh-oh. We're in the radian world again. It's going to be 1.5, comma, I'm on 32, sorry. 3.62 radians. There's no degree symbol. They clearly mean radians here. So x is going to be equal to 1.5 times the cosine of 3.67 radians. Make sure it's radians. I'm just going to leave that because I'm just going to do that in my calculator. Y is going to be 1.5 times the sine of 3.67 radians. And here we go. Am I in radian mode still? I am. 1.5 times the cosine of 3.67. And I'm getting negative. I'm going to go negative 1.30 because it is. And the other one is, I'll go 2 decimal points. I don't know why, just guys. And the other one is 1.5 times the sine of 3.67 radians. And I'm getting negative 0.76. So the ordered pair is negative 1.30, comma, negative 0.76. Okay. And 36. Let me read it. Use a graphing utility. We're not going to do that. To find the rectangular coordinates of the point given in polar coordinates. Okay. So I will need a calculator, though. I will need a calculator. Yep. So this is going to be for 36. The polar coordinates are 4, 11 pi over 9. And that's not a unit circle value, so I will need to use a calculator. So x is going to be equal to r times the cosine of 11 pi over 9 radians. Radians, make sure you're in radians. And y is going to equal to 4 times the cosine of 11 pi over 9 radians. All right, let's get a calculator and do this. It's going to be 4 times the cosine of 11 times pi divided by 9. And I'm getting negative 3.06. I'll do 2 again. 2 decimal points. And, oh, I wrote cosine twice. This should be sine. Should be sine. It's going to be 4 times the sine of 11 times pi. I think you're right, 11 pi. It works. All over 9. This is negative 2.57. So as an ordered pair, it's negative 3.06, comma, negative 2.57. Throw that one away. Oh, I have a whole other side to use. That's good. Excuse me. $40. The point in polar form is 5.4. That's the R value. The theta value is 2.85 radians. No degree symbol, no degree symbol. So that means x is equal to, this is the last one for polar, going from polar to rectangular, then we're going to go from rectangular to polar. 5.4 times the cosine of 2.85 radians, y is going to be 5.4 times the sine of 2.85 radians, and I'm just going to use my calculator, make sure I'm in radian mode. 5.4 times the cosine, 2.85 radians. Oops, yeah, I got it. Negative 5.17 about, and I got 5.4 times the sine of 2.85 radians, and I'm getting 1.55. I don't know why I want to do the x one again. Something didn't feel right. Yeah, that's right. So the order pair is negative 5.17, comma 1.55. That's x, y now. I changed from r theta. Again, that's in radians though, to x, y. Okay. 44 is 2, 2. I already know what it is. Anybody that has been around enough, or even you guys probably got it. So it's 2 comma 2. Let's talk about it. That's x and y. So now we have to turn that to r and theta. R is always the square root of x squared plus y squared. And theta is the arctangent of y over x. But remember what I told you. You better think about that value, because the angle that they give you in the calculator is going to be a principal value, and you might not want the principal value. You might have to add 180. So you have to kind of consider what the calculator gave you and what you were looking for. All right, 2, 2. Well, the r value is going to be the square root of 2 squared plus 2 squared, which is, right, it's 4 plus 4, which is the square root of 8, which is 2 root 2. R is 2 root 2. And theta is the arctangent of 2 over 2, which is the arctangent of 1, which is exactly equal to 45 degrees. Right on the dot. I don't need a calculator for that, right? Tangent of 45 is 1. So that's it. So I'm going to go ahead and now list that as 2 root 2 comma 45 degrees. Of course, I could do pi over 4. If you feel strongly you'd rather put it in radians, I definitely get that. That'd be fine. 48. And I want to talk about this. This is 3, 0. Does everybody see if I go 3 to the right and up and down 0? Does everybody see that's going to be 3 comma 0 degrees? I hope so. But anyway, here we, okay, you should be able to just write 3 comma, all right. Right? That's 3, 0 degrees. Anyway, here we go. Let's do it though. So r, it's just killing me to do this. R is the square root of 3 squared plus 0 squared, which is the square root of 9, which is 3. And theta is the arctangent. It's the arctangent of y over x, which is 0, And, but you have to be careful because it could be 180 too, right? In which case tangent 180 is also 0. So be careful. You still have to interpret the answer of this. Your calculator gives you 0 degrees, which yet, or you know 0 degrees is 0. And so because I'm going to the right 3, that's going to be 0 degrees. If I'd gone to the left 3, that'd be 180 degrees. So as an ordered pair, it's r comma theta, and that's it. 52, it's -4 comma -3. So this is going to be r is equal to the square root of -4 squared plus -3 squared, which is 5. If that's okay, right? 16 plus 9, which is what this is the 3, 4, 5 triangle. 2 legs are 3 and 4. It means the hypotenuse is 5. But anyway, that's 16 plus 9, which is 25 squared. 25 is 5. Okay, and then theta is going to be the arctangent of -3 over -4. The two negatives cancel. And this is the one I'm going to get the wrong answer in the calculator. It's not wrong, just gave me the principal value. And I have to know I have to add 180. Here we go. I'm going to do the arctangent of -3 over -4, which you could cancel the negatives if you want or not. Oh, I'm in radian mode. Let's go in degrees. Let's go back. Arctangent of 3/4. And I'm getting 36.87. But 38.87 is in the first quadrant. The first quadrant is positive x and positive y. I don't want that. I want negative x and negative y. I want the third quadrant. So I'm going to have to add 180 to this. And I'll get 216.87. So that's going to be listed as 5 comma 216.87 degrees. And 56, that's a unit circle value I recognize. The ordered pair is the x value is -1, the y value is √3. So r is going to be the square root of -1 squared plus √3 squared, which is 1 plus 3, which is 4, and the square root of 4 is 2. And theta is going to be the arctangent of y over x, which is √3, right? So I would do it this way. I would not get a calculator for this one because it's a unit circle value. right? The tangent of a 60-degree reference angle is root 3 over 1, or root 3. And then I would just go, okay, I know it's a 60-degree reference angle in one of the quadrants, but what quadrant am I supposed to be in? I'm supposed to be left 1 and up. I'm supposed to be left and up, which is quadrant 2. So a 60-degree reference angle in quadrant 2 is going to be equal to 150 degrees. Now, let's just say you didn't do that, but I hope you do. Let's say you said, Freund, let's see, I'm going to do the arc, clear that, arc tangent of negative root 3 over 1, which is negative root 3, and you get negative 60. You get negative 6, oh, 120. Wait a second, what did I say? Oh, duh. Let me go back. I said it should be a 60-degree reference angle in quadrant 2, which would make this 120, you guys, which would make this 120, 60-degree reference angle. I don't know what I was thinking. And so, other than these long days, so this is 120, right? 120. So in my calculator, though, it gave me negative 60 when I tried it. And then I got to think to myself, negative 60 in is quadrant 4, which is positive x, negative y. Well, I want just the opposite of that. I don't want quadrant 4. I want negative x, positive y. I want to be there in quadrant 2. So I'd have to add 180 to that, and you get the right. I hope you don't have to do it this way, but there it is. So, oh, listed as an ordered pair, 2, 120. 2, 120. And then 60 is 7, 15. So R is going to be the square root of 7 squared plus 15 squared. That is not a Pythagorean triple that I'm aware of. Let's go 1 decimal point this time. Square root of 7 squared plus 15 squared is about 16.6. Rounded though. And then theta is in the first quadrant, right? Positive x, positive y. So it's going to be a first quadrant angle. It's going to be the arc tangent of 15 over 7. We do that on my calculator. Arc tangent of 15 divided by 7. I'm getting about 64.98. So it's going to be about 65.0, rounding it to the nearest 1/10. And I would want to put the 0.0 because it's 64.98310.652. All right, so that's that one. A point in rectangle is given, convert to, okay, there we go. Use a graph utility. So we're on, which one are we on? 64. Let's read the instructions for this now. Use a graphing utility to find one set of polar coordinates of the point given in rectangular. Okay, so we're again switching over to rectangular, polar rather from rectangular. It's going to be 7, -2 is what it is in rectangular form. Yes, I agree with you. These so far are just repetitive and easy, but they're going to get harder here in a moment. It's going to be 7 squared plus -2 squared, which is the square root of 49 plus 4, which is 53. And theta is going to be the arc tangent of y over x. And let's think about it. It's positive x, negative y, which is fourth quadrant. And my calculator does give me fourth quadrant. That's a principal value. It's going to be a negative angle that I'm going to want to get coterminal to by adding 360, just to put it in proper form. I wouldn't take off points if you gave me the negative angle, but just saying. All right, here we go. It's going to be the arc tangent of, what did I say? -2/7. And this gave me -15.94 degrees. Remember, the convention is you give an angle between 0 and 360. So add 360 to that. And I'm going to write 344.1. Which is then square root of 53, 344.1 degrees. And by the way, I forgot to write this one because I always want to write them as an ordered pair. As that. All right, 68. I might have to take a break and get a water and close my eyes a second. I'm getting kind of punchy. It's going to be 9/5, 11/2. And that's going to be r equals the square root of 9/5 squared plus 11/2 squared. Sorry. Which means r is going to be the square root of 81 over 25 plus 121 over 4. I'm curious if they gave an exact value in the book. Here, let me just see. What number is this? 68. They sure as heck did. They sure as heck did. And they gave the angle in radians. Whatever. All right, here we go. Let's see if I can do it. I'm kind of curious if I can do it. So it's going to be equal to the square root. I've got to get a common denominator of 100. So this one I'll multiply by 4 over 4. That's 324 over 100. Plus this one I'm going to multiply by 25 over 25, which is 125. Excuse me. Yeah, 25 times 121, which is 15,125 over 100, which is add 324, which is the square root of 15,449 over the square root of 100, which is obviously over 10 here. Let me see what they have in the back of the book again. 68. Okay, wait. 81 over 25, 11, 121 over 4, 4 over 4. Oh, I think I did 125. That's why. That should be 25. Yeah, I think I did 125, you guys. That's not the right answer. I think I did. I'm getting, you guys, I'm telling you, I think I need a break. Times what? Yeah, that's 3,025. My bad. And then when you add those together, plus 324, yeah, that's the answer they have in the book. This radical is, it's the square root of 3349 over 10. Sorry, over 10. And theta is going to be the arc tangent. We'll do it in degrees though, of y over x, which is 11 over 2 divided by 9 over 5x. And then theta would be the arc tangent of dividing fractions. As easy as pi, you flip it over and multiply. So if I flip the 5 to the top, that'd be 5 times 11 would be 55, divided by 2 times 9 is 18. Here we go, arc tangent of 55 divided by 18. And I'm getting about 71.9. Let's go 1 decimal point. And so there it is. Listed as an ordered pair, it would be the square root of 3349, 49 divided by 10, comma, about 71.9 degrees. Okay, that was kind of a rough one, 72. Now we're finally getting there. We have to convert from rectangular to polar this time. So 72 is x squared plus y squared equals 16. So what is x squared? What is x squared plus y squared? It is r squared, right? Leg squared plus leg squared equals hypotenuse squared equals 16. Divide both sides, or excuse me, take the square root of each side, and you get r equals 4. So that makes sense, right? That's a circle. If we keep it in rectangular form, that's a circle whose center is at 0, 0, and whose radius is 4. And this is a circle whose center is at the pole and whose radius is 4. So yeah, same thing, just in polar form. And this is now going to be 76, which is x equals a. Let me think about what I'm doing here. Yeah, I think I got it. Okay, sorry, I had to think about it for a second. So what is x in the polar world? It is, I should probably take a break for just a little bit and get a drink. So x in the polar world is equal to r cosine of theta equals a. Should have thought of this. In which case we can divide both sides by the cosine of theta. And this would be r equals a divided by the cosine of theta, which would then be equal to r is equal to 1 divided by cosine is secant. So a secant of theta. And there it is. R equals a secant of theta. So we took it from rectangular to polar. We're on 80. 80 is equal to 3x plus 5y. All right, this is a line equals 0. We're at 80. Okay, well, I'm not sure. Let me keep going. So x is equal to r cosine of theta. This would be 3 times r cosine of theta. And y is equal to r sine of theta. Yeah, I think I know what it is. Yeah. I think I've even asked this question before. Add a 2 to both sides. 3r cosine of theta plus 5r sine of theta equals 2. Factor out an r out of both of these. This would be r times 3 cosine of theta plus 5 sine of theta equals 2. And then divide the whole left side by 3 cosine theta plus 5 sine theta. The whole right side by 3 cosine theta plus 5 sine theta. They cancel, and you get putting it into rectangular form, polar form, which is like r equals or r squared equals. R equals this expression over here. Let me just make sure that's right. 80. Yeah, that's it. 84 is x squared plus y squared is equal to 9a squared. And so now x squared plus y, this is an easy one. X squared plus y squared is r squared equals 9a squared. Take the square root of each side, and you would just get r equals 3a. That's pretty simple and fast. And 88 is x squared plus y squared squared is equal to 9 times x squared minus y squared. Okay, I guess that's it. Okay. Sorry, that's the problem. I think I might got it. I might have it. Here we go. That's going to be x squared plus y squared squared is equal to 9 times. I'm going to convert these each. What does x equal? Here, actually, I take it back. Let's go ahead and convert everything right now. So x squared plus y squared is r squared. It's going to be r squared squared is equal to 9 times. And what is x? It's r cosine theta, and that's being squared. It's kind of a rough one. And I think I see it, though. I could be wrong. R sine of theta squared, like this. Okay. Now, r squared, this is where you multiply exponents. The r to the 4th is equal to 9 times. Let's go ahead and this is r. Let's don't quite do that. Let's do one more step first. See, remember, if you have a times b to the m, that's a to the m times b to the m. So it's going to be r squared cosine squared of theta. Oh my God, yeah. Just you guys, good luck. Sine squared of theta. And now I can factor out an r squared. We do that. So this is going to be r to the 4th is equal to 9r squared. And it's going to be now cosine squared of theta minus sine squared of theta. And you ready? This is not the hard part. Divide both sides by r squared. And the r squareds cancel. And then r to the 4th over r squared is r squared equals 9 times. I bet this is it. You ready? Okay, you ready? Anybody remember that identity? That's a double angle identity. That's the cosine of 2 theta. And so you're supposed to memorize that double angle identity, but let me look. It's 88. I bet it is though. Yep, that's the answer. And 92. Okay, now, so what have we been doing? We've had rectangular equations that we converted to polar. And now we're going to take some polar equations and convert them to rectangular. So for 92, it is r equals 2 cosine of theta. It's going to be r equals 2. And what is the cosine of theta? It is x divided by r. It is, but I'm just thinking about it. And multiply both sides by r, and you get r squared equals 2x. Got it? Okay, wait a minute. I didn't convert this. What is r squared? It is x squared plus y squared, which would be equal to 2x. And I'm not sure the format they want this in. Let's just see. Let's just see. This is 92. Okay. They set one side equal to 0. That's why I'm like, I'm not. Okay, so they did it in general form. Maybe I should just do that from now on. So this was x squared plus y squared minus 2x equals 0 by subtracting a 2x. And now it's in general form, right? All right, and 96 is theta. Oh, pay attention to this one. Theta is equal to 5 pi over 3. And we want to convert that to rectangular. We could take the tangent of both sides. We get the tangent of theta is equal to the tangent of 5 pi over 3. All right, what is the tangent of theta? It's y over, not r, y over x. And what is the tangent of 5 pi over 3? It's negative root 3. All right, yeah, negative root 3. It's a 60-degree reference angle in quadrant 3. Oh, positive. My bad. Tangent is positive in the. Wait a minute. That's a fourth quadrant. Oh, Freud. I definitely need to take a break. That's a fourth quadrant angle. That's a 300-degree angle, right? It's 5 60-degree angles. Freud, you're killing me. That's negative root 3. Multiply both sides by x, and this will become y equals negative root 3x. It's a line. Think of it as plus 0. It's in y equals mx plus b format. It's a line. The slope of it is negative root 3, and the y-intercept is 0. And that makes sense, right? That's a line. This is like going 5 pi over 3 and just let r be anything you want it to be. That would be a straight line. All righty, let's go 100. R equals 10. So another way to write this would be, what is r? It's the square root of x squared plus y squared equals 10. Square both sides, you get x squared plus y squared equals 100. So it makes sense, right? In rectangular form, that's going to be a circle whose center is at 0, 0, and the radius is 10. And in polar form, that's going to be a circle whose center is at the pole and whose radius is 10. So same thing. This is 104. And this is r equals negative secant of theta. So this is going to be r equals negative. Secant is r over x. It's hypotenuse over adjacent. And okay, divide both sides by r. The r's are going to cancel. And you get 1 equals negative 1 over x. Multiply both sides by x, you get x equals negative 1, which is a vertical line, right? In rectangular coordinates, a vertical line through negative 1. And apparently that's what you would get here. I can try it, but I'm not going to. Let me just see if that's right. 104. Yeah, x equals negative 1, that's it. 108. R squared equals the cosine of 2 theta. Yeah. Okay, and I think there's going to be that identity, I think. But we'll try it. We'll try it and see. So what is r squared? It's x squared plus y squared. And what is the cosine of 2 theta? It's x squared minus y squared. That's the cosine. That's a double angle identity. What am I doing? Hold on, that's not right. It's idiot. God dang it. You write this again. The cosine of 2 theta is equal to cosine squared of theta minus sine squared of theta. I definitely need to take a break. I'm wavering. I think I'm going to I keep on saying it. I'm going to get a drink of water, please. Okay, so let me keep going. So far, but I have never changed these. I've never changed these. You know what? I kind of think I want to keep that as, now that I'm seeing what's happening. I want to keep that as r squared. Just for a second, you'll see why in a moment. So what is the cosine of theta? It's x over r squared minus what is sine of theta? It's y over r squared. So it's going to be r squared is equal to x squared minus y squared over r squared if I get a common denominator. Okay, and multiply both sides by r squared. And that would be r to the fourth is equal to x squared minus y squared. And so this would be x squared plus y squared squared is equal to x squared minus y squared. And I don't see any way that can be reduced. But let me look in the back. That's it. That's it. That's the answer. That's a weird one, you guys. That's a weird one. I said I was going to get a drink of water. Let me try one more. I'm going to drink. I can't quit. We're only going to 124 anyway. We're getting pretty close. I do need a drink of water though. This is r equals 1 over 1 minus the cosine of theta. Multiply both sides by 1 minus the cosine of theta, and I get r minus r cosine of theta is equal to 1. Okay, let's go ahead and write the cosine of theta. That's going to be r minus r, and the cosine of theta is x over r is equal to 1. And these r's cancel. So that's going to be r minus x equals 1. Now let's go ahead and change this r. Let's add an x to both sides. And this would be r equals x plus 1. Okay, let's go ahead and change r to the square root of x squared, because remember, everything's got to be in terms of x and y for it to be converted to rectangular form, right? And like the other one's got to be, everything's got to be in terms of r and theta. This one, everything has to be in terms of, it's given to you in terms of r and theta. And in this one, you have to give everything in terms of x and y. So this is going to be square root of x squared plus y squared equals x plus 1. And if you square both sides, that'd be x squared plus y squared is equal to x squared plus 2x plus 1. Subtracting x squared from both sides. And I think I'm getting y squared equals 2x plus 1. And maybe they did it in I bet you they did it in standard form. Excuse me, general form. I bet they wrote y squared minus 2x minus 1 equals 0. But let me just see. Oh, come on. What number was this? 112. No, they didn't. They didn't. They wrote it like this. So the answer is y squared equals 2x plus 1. Keep going. I'm gonna must. Even though I'm kind of getting raspy as I can hear it. 116 is r equals 5 over sine of theta minus 4 cosine of theta. Let's try this first. Before I switch things over, let me just do this first. R equals 5 over, I'm going to write the sine of theta. as y over r minus 4 times, I need to make sure I wrote it down right. Yeah, it is. And that's going to be 4x over r is what the cosine of theta is, which is 5 over y minus 4 over r, because there's a common denominator. So now I could flip it over, right? Dividing fractions is easy as pi. Flip this bottom one over and multiply. And this would be r equals 5r divided by y minus 4. Divide both sides by r. The r's go away. And you get 1 equals 5 over y minus 4. Multiply both sides by y minus 4. And that would be y minus 4 equals 5. That's y equals 9. I sense I did something wrong, because I don't think it should come out to be a line. Oh, way freaking off. Way off. All right, let me try this again. And if I can't, then I will get a drink of water and see if I can work through it. Let me just see if I can figure out my error. Let me first make sure I wrote it down right. Sine of theta minus 4 cosine of theta. And I called the sine of theta y over r, which it is. I called the cosine of theta x over r, which it is, adjacent over hypotenuse. This would be a common denominator. Oh, 4x. I wrote 4. This would be 4x if you flip it over. This would be 4x. Oh, I think that's the answer. 4x. Let me just start from here. Let me just do it from here. Multiply both sides by y minus 4x, and you get y minus 4x equals 5. And then add a 4 to both sides, you get y equals 4x plus 5. Sorry about that. Somehow I dropped that 4 when I went down to here, and that should have been there. Let me make sure that was it, though. They wrote the order different, but that's okay. Let's go with that. It's the same thing as what they have in the back of the book. 120. Okay. So what do we do? What are we doing all this time? In this section, we were taking a polar equation and in terms of r and theta, and writing it in terms of x and y, so that everything was in terms of x and y instead. That's called rectangular. Now we're going to go the other way. Now we're going to take something that's in rectangular form, and we're going to go to polar, and we're going to go to polar. So this is going to be equal to, theta is equal to 3 pi over 4. Okay. We did one like this before already. Take the tangent of both sides. This would be the tangent of theta is equal to the tangent 3 pi over 4. And the tangent of theta is y over x. And that's a 45-degree reference angle in quadrant 2. And the tangent of 135, which is what that is -1. Multiply both sides by x, and you get y equals -x. How could it? Yeah, it is. It's that. Y equals -x. I can see what it should look like here, and it should be the same. And then 124 is r equals -3 sine of theta. Alrighty. So this is r equals -3, and what is the sine of theta? It is y over r. Multiply both sides by r, and you get r squared equals -3y. And then you could write r squared as x squared plus y squared equals -3y. And I guess that's okay. I mean, I could move everything to one side and have it standard form, a general form. But let me just see what they wrote. I'm on the wrong page here. Oh, okay. I have some work to do. I see what they did. I had some work to do. I should have seen it. I should have seen it. Okay, this is a good one to end on. It's a good one. This is a doozy. Okay, let's set one side equal to 0. And it's going to be x squared plus y squared minus 3y equals to 0. get all the x's together, get all the y's together, and complete the square twice, except I only need to complete it once because x is a perfect square. So how do we do it? We do b squared over 4a, so b squared would be 9, over 4 times 1 is 4, so 9/4, which means I have to add a 9/4, excuse me, over here. So this is going to be x squared plus y minus 3/2 squared is equal to 9/4. And that is it, you guys. It's a circle. It's a circle. Where's the center of the circle? It's 0 left and right and up 3/2, 1.5. And the radius of the circle is 3/2, right? Square root, it's because that's r, that represents r squared, right? It's in the form of x minus h squared plus y minus k squared is equal to r squared. So h is 0, k is positive 3/2, and r is the square root of that number, which means you got to take the square root of the numerator and the square root of the denominator, which is 3/2. So that's the radius is 3/2. And you could graph it. I think there's a picture maybe you see. Yep. And there's a picture if you were to graph. Well, you don't need to do it. You can. I think you can visualize that in your head. I think you can visualize a circle whose center is at 0, 1.5, and whose radius is 1.5. Okay. Here's the picture of that. All right, that's a wrap. Throw some papers away. That one is for you. I don't know why I'm still talking. That I'm going to go through. I could use a little bit, but I'm going to throw it away. All right, catch in class.